Ladies and gentlemen, distinguished guests, and esteemed colleagues, good morning. I, Sahil Yadav, stand before you today with great pleasure and a profound sense of privilege as we gather for the illustration of 5th International Conference on Recent Developments in Control, Automation and Power Engineering, RDCAPE 2023. On behalf of the organizing committee, I extend a warm and heartfelt welcome to each and every one of you. This conference serves as a beacon of knowledge and innovation, convening brilliant minds from around the world to exchange ideas, discuss cutting edge research, and collaborate on solutions to the most pressing challenges of our time. We are now embarking upon our first technical session of the day, centered on power electronic drives and applications. The esteemed session person for this session are Dr. Farhad Ilahi Baksh, Assistant Professor, Electrical Engineering Department, NIT Srinagar, India. Dr. Amit Kumar Chaudhary, Assistant Professor in the Department of Electrical Engineering at BIT Sindri, Dhanbad, Jharkhand.
Allow me the privilege of introducing a first session chairperson, Dr. Farhad Ilahi Baksh, whose remarkable profile reflects his dedication to the field. Dr. Farhad Ilahi Baksh received BTech degree in the Electrical Engineering and MTech degree in Power Systems and Drives from Aligarh Muslim University, Aligarh, India in 2010 and 12, respectively. Then he pursued PhD from the Indian Institute of Technology, Roorkee, India in 2017. During his PhD, he developed a few methods for grid integration for wind energy generation systems, which has been recognized worldwide. He developed an automatic solar tracking system which has been appreciated by IEEE India Council, Center for Embedded Product Design, Center for Electronic Design and Technology, Netaji Subhash Institute of Technology in association with IEEE Delhi section and IEEE CAS Bangalore chapter. Currently, he is serving as an assistant professor in Department of Electrical Engineering, National Institute of Technology, Srinagar, Jammu and Kashmir, India. He is a founder and consular of IEEE Student Branch, NIT Srinagar. He has won 10 for 10 Typhoon. He has won 10 for 10 Typhoon HIL Award from Switzerland, Europe. He delivered a number of keynote talks, invited talks, and expert lectures at national and international level in conferences, workshops, etc., and etc. He has more than 60 published papers in Scopus or Web of Science based international reputed journals and conferences. He has also published one Springer book and more than 10 book chapters. Many times he got Best Paper Awards in international conferences. Moreover, he has Indian and Australian granted patents in his credit. Recently, he has been enlightened with Award of Excellence in Research by Volway International. He served as lead guest editor in IET Generation, Transmission and Distribution Journal, guest editor in IET Renewable Power Generation Journal, and guest editor of Distributed Generation and Alternative Energy Journal. He is the associate editor of Distributed Generation and Alternative Energy Journal, lead guest editor in IET Power Electronics Journal, guest editor in Renewable Energy Focus, Elsevier, guest editor in Frontiers in Energy Research, and guest editor in Recent Advances in Electrical and Electronic Engineering. His research area of interests includes performance analysis and new applications of variable frequency transformer, application of power electronics and drives in renewable energy systems, multi-level converters, alternative energy vehicles, and multi-phase drives. Now I am introducing a second chairperson, Dr. Amit Kumar Chaudhary. He is assistant professor in the Department of Electrical Engineering at BIT Sindri, Dhanbad, Jharkhand. He has done his PhD from the Department of Electrical Engineering from Indian Institute of Technology, Varanasi, UP, India. He is a member of various professional bodies that includes ACDOS, IDS, IEEE, IET, and SIM. He has published several research papers in international journal and conferences of repute.
Ladies and gentlemen, now I would like to invite Dr. Farhad Ilahi Baksh, a respected session chair, to share his insights and guidance as we begin this informative technical session on power of electronic devices and applications.
Uh, yes, very good morning to one and all who is present here. Am I audible?
Yes, sir, you are audible.
Okay. Okay, thank you for such a nice introduction. And I think the session has already been delayed. We should start it as soon as possible.
Okay, sir. I now hand over this session to a session chairperson who will guide us through this session.
Kindly start the paper ID 101.
So paper ID 101, a noble PV module rearrangement approach for enhancement of productivity of total cross-tied PV array under PSCs by Isha Mishra. Please start the presentation. Sir, can we start with the next one?
Yes, please.
Next ID 220, universal filters for low voltage analog applications using bulk driven current conveyors by Anu Tong. Start the presentation, please.
I hope I'm audible to everyone.
Yes, you are audible.
Okay. Yeah, so good morning everyone. My paper ID is 220 and I'm presenting this paper which is titled Universal Filters for Low Voltage Analog Applications using Bulk Driven Current Conveyors. So the table of content is like first the introduction will be presented, then a brief overview of bulk driven current conveyors, then MOSFET, bulk driven MOSFETs will be presented. Then I'll discuss the schematics of the plus and minus type bulk driven current conveyors. Further, I will be discussing the universal filters, which are multiple input single output filters designed with these bulk driven current conveyors. Then I will be presenting network analysis, results discussion, conclusion, and my list of references. So, in this study, I have presented 4 topologies, which are universal filters and based on bulk-driven second-generation current conveyors. A detailed circuit analysis is also given. I have used a voltage supply of plus minus 0.5 volts, and all standard responses of a universal filter are presented in voltage mode. I have done piece-wise simulations with 0.18 microamp CMOS technology. So what are bulk driven current conveyors? So first we had the original second generation of current conveyors, which are the most versatile and useful current mode building blocks. In those, the voltage which is provided at the Y terminal is copied as the X terminal, and the current which is applied at the X terminal is get copies on the Z terminal. Whereas the Y terminal has an infinite input impedance. So this is the main characteristic matrix of the current conveyor second generation. Now I have implemented the bulk driven technique in the transistors, and with this technique experimentally it has been found to decrease or partially or completely eliminate the threshold voltage requirements of a MOSFET. So I have simulated one N-type MOSFET with gate-driven and bulk-driven both the techniques to experimentally verify the fact that the threshold voltage can be reduced. So on the graph in figure 3, you can see that in gate-driven NMOS, the linear characteristics of the current are coming around 0.372. It is the voltage at which we can see the linear characteristics of the current, whereas for the different transistor sizing, the bulk driven NMOS are being able to operate in the negative and the positive region both. So this is the feature of using this technique. So these two schematics I have drawn. So first one is for the p-type, for the plus type of CC2, and the second one is for the minus type CC2. I have verified the current characteristics, which I was saying that the current get copied on the Z terminal from the X terminal. Also, I have verified the voltage characteristics, the characteristics of the matrix which I have shown, and I have found out the parameters. It can be seen in the table 1. So these are the characteristics of the main schematic and the block. Further, these are my 4 filters which I have implemented using the bulk-driven current conveyors, plus type and minus type. And table 2 shows the mode of operation and the settings which are required to achieve the standard responses of a universal filter. We can achieve all the responses: low pass, high pass, band pass, notch, and all pass. So here I have presented the network analysis. I am presenting the output responses, voltage output for the first 3 configuration. It is same, and an expression in equation 3 is given for the 4th configuration here. I have also done the non-ideal analysis, wherein I have considered alpha and beta, which are the non-unity transfer gains for current and voltage. With that, I have done the sensitivity analysis. All sensitivities are within the range -1 to 1. These are the filter responses for the 4 config topologies I have simulated, and the settings are shown for the various values of resistor and capacitor. So in my paper, I have implemented a bulk-driven second generation current conveyors operating at ±0.5 volts. I am achieving all standard filter configuration. All the responses are being achieved, and I have given the simulation for a central frequency of 159 kilohertz and a quality factor of 1 by keeping different settings for the resistors and capacitances as given in the slide. And in my work, I am able to implement the bulk-driven current conveyor with a low voltage, whereas in the literature you will find it implemented for voltage levels which are greater than equal to 1, and also very high voltage which are greater than equal to 5 voltage supply. And also, as compared to the references 14 and others which I am mentioning, we are able to reduce the number of components used, and also the component count. We are able to tune the quality factor independently, which is a great feature. And for the references 11 to 14, 16 to 40, we are able to overcome most of the shortcomings. I have also presented this in the form of a table. So my criteria of comparison are technology and voltage supply A, B, number of inputs, C, the number of active elements, D, the number of passive elements, E, the control on quality factor, F, matching conditions, and G, whether we are able to operate it in all low voltage levels. So I have made this table of comparison along with the references number. So whenever we'll try to compare our topologies, UF1, UF2, UF3, UF4 with the others, we are able to achieve the responses on a low voltage level, and further the research is being done on ultra low voltage levels, which are even less than ±0.4, 0.5 voltage. So the research currently is in that area, and we are able to reconfigure the quality factor as well. So now I am concluding my presentation with the information I have presented. I have designed the bulk-driven current conveyors and further implemented 4 multiple input single output filters on TSMC 0.18 microamp technology, and they are able to operate at low voltage levels. So they can be further explored in the area of low voltage, low power, and low frequency circuits. And these are my references. Thank you.
Thank you, Anupam. Hello.
Yes, sir. Yes, sir.
Yeah, it was good presentation. Actually, I want to know which software you have used to simulate it.
Sir, it's the PSpice software.
PSpice software.
Yes, sir. So there are different versions. PSpice, HSpice. We are using PSpice.
Okay. You should mention it somewhere in the slides also.
Sure, sir. On the first slide, P-Spice.
Okay, it is written, but okay, thank you.
Okay, sir. Sorry, I forgot.
Second thing is that you are dealing. Can you come to the circuit diagram?
Yes, sir.
No, next. Yes, here.
Yeah.
Just slide number 6.
Oh, sir. Just slide number 6. Yes.
I think
This one.
your share screen is not visible to me.
So, okay, sir. I'll share once again. I think someone is. I'll reshare, sir. Yes, sir. I think it's visible now.
Slide number 6, please come
Yeah,
to
sir.
slide
Yes,
number
sir.
6.
Yes, sir.
Previous one. Okay, so here you are using IGBTs. Is this actually a figure or MOSFETs? These are MOSFETs, I think, huh?
These are MOSFETs, sir. So
Okay,
we are using bulk-driven technique within the MOSFETs.
Okay. Now I want to know these. Are you dealing with the electronic MOSFET or power electronics MOSFET?
No, sir. It's electronic MOSFET. So the paper belongs to integrated circuit design with CMOS.
Basically, I was just confused because the session is going on
Yeah.
power
Yes.
electronics drives and applications,
Yes,
and
sir.
you are basically presenting the electronic MOSFET. Okay,
Yes.
not an issue. But can you tell me, you somewhere you have mentioned you are operating it at 159 kilohertz.
Yes, sir. So
What
with
is
this,
the
yeah.
I saw somewhere. I'm not sure.
Yes.
Somewhere it has been mentioned.
So the responses are simulated on the center frequency. You can see from the notch filter.
So obviously the MOSFETs are also working on the 159 kilohertz.
Yes, sir, they are working. But furthering this work, which I am not presenting here, I am able to simulate circuits with bulk-driven MOSFET at very low frequency, like 1 or 2 kilohertz, or even less than that in hertz. Also, I am able to get. So those circuits, they are really vouched for the biomedical areas. I mean, somewhere we can implement the module in those circuits.
That's why you are saying it as a universal filter.
No, sir, universal filter it is called because we are getting all the functions, like all the filtering responses, all pass, band pass, high pass, notch, low pass are given by a single filter. It's not like a single filter is giving only one.
Yeah. That I am understanding.
Yes.
I want to know what is the practical range of the frequency in a electronic MOSFET.
In a MOSFET, you are saying?
Yeah. Up to how much frequency you can operate it?
Sir, I think I will not be able to mention it as of now. I mean, I couldn't recollect the exact values, but I mean, when I talk about MOSFETs, current conveyors with MOSFETs, there are modules which can even go to gigahertz. So, depending upon which kind of application we are targeting, I mean, most of the work is with MOSFETs in current conveyors with high frequency values. And right now, the current research is with MOSFETs in current conveyors in very low frequency area. So, trying to achieve very low frequencies in the field of current.
But while simulating, you have taken a certain configuration of MOSFET, some certain practical configuration of MOSFET, single MOSFET.
Yes, sir. To present that the threshold limitation is being eliminated here. So with this red curve, this is a general NMOS, and you can see like the threshold voltage is 0.372. At this value, you are able to see that the linear value of current is being achieved. Whereas in bulk driven, we can see these values are very less. So for the same W by L ratio, the value is near minus 0.27. Like that.
Okay, thank you. I should pass the session to the next session chair.
Okay.
Prab, sir.
Yeah, yes, sir. How are you?
Thank you, sir. How are you?
I am fine, sir.
You had a nice question session, sir. One question means one suggestion I should give to the author Anupam.
Yes, sir. Thank you
Like
so much.
you might be seeing that all your slides are full of content.
Yes, sir. Yes, sir. I realize that.
And PowerPoint presentation is like presentation should be in
Yes,
bullets
sir.
and it should be only point wise.
Sir, actually, the amount of work I am presenting in this paper is, I mean, more
Yeah,
than.
that's very good and commendable.
Yeah.
You should present this in paper, but when you are going for a paper slide or make presentation, you may try to make it as means.
Sure, sir.
conscious.
I'll
Okay.
take care of it. Next.
Okay. This is from my side.
Yes, sir.
Thank you, Anu, and all the best.
Thank you so much, sir.
Thank you, ma'am. Now we move to the next paper ID 101 on the topic a novel PV module arrangement approach for enhancement of productivity of total cross-tied PV array under PSCs, presented by Isha Mishra.
Hello, am I audible?
Yes, ma'am.
Okay, just a minute, I'll share my screen. My screen visible?
Yes, it's visible.
Okay, so
Please, I'm sorry to disturb. Please, could you just put your slideshow on?
hello?
Please, could you put your slides into presentation mode, the slideshow?
Okay, okay.
Thank you.
Okay, so the title of my paper is A Novel PV Module Rearrangement Approach for Enhancement of Productivity of TCT PV Array under PSCs, that is partial shading condition. So first I'll be giving some introduction about my work, and these are the contents. So then I'll be talking about my proposed approach. Then I'll be talking about the shading distribution and the results through the power curves, which are the graphs. And then I'll be talking about the performance parameters. And then I'll be finally concluding my PPT. So, renewable energy sources, especially solar energy, which we all know is affordable as compared to the other sources of renewable energy. It is modular, portable, and the installation process is simpler compared to others. So this is the reason it has become the most popular option for generating power. So however, the varied temperatures and non-uniform irradiation conditions of PV systems experience have a detrimental effect on PV power generation. So one of the main environmental factors affecting PV systems' maximum power output, complexity of MPPT, that is maximum power point tracking, because of the production of multiple peaks and durability, is partial shading. So in the current work, a unique strategy based on the concept of RADFI is provided to protect the PV systems from the above negative effects of partial shading. The following, which I'm going to tell now, are the contributions made by our article. So, a novel technique based on the idea of repeated application of a derived fundamental integer is introduced to distribute the shadow shading uniformly across and boost the output power, reducing the mismatch power losses. And with artificially created shading situations, extensive simulation validation done by us evaluates the effectiveness of the suggested PVRA layout. So, along with the traditional TCT configuration, a thorough comparative analysis has been done with existing configurations. According to the findings, PV power generation rose by up to 34.12% in some situations. So, we have majorly adopted two approaches to solve this issue. So, the number one is static reconfiguration, that is relocation of the PV arrays physically by keeping the electrical connections intact. And the second is dynamic reconfiguration, that is the electrical connections of the area are rearranged. So many reconfiguration algorithms have been proposed using the approaches mentioned. Some use methodologies such as two fuzzy logic, chaos Baker map, dominant square matrix, and Parquet square based approach, Sudoku, and there are several others. So these are just the various variations. So our algorithm, what it does is it employs basic mathematical operations to reach the desired reconfiguration, ensuring that the reconfigured PVRA can function well under PSC, executing shading dispersion with greater efficiency. So what we have done is that a PV array consisting of multiple PV modules of a number of rows, let's say, let's say n number of rows and the number of columns is taken. So if the number of rows is P and the number of columns is Q, so this makes the dimensions of the array P by Q. And the array is named A. So excuse me. So the index of any PV module and the array A is we have denoted it as ij, where I is the row and j is the column of the element. I will present the algorithm through which you will understand it better. So the step 1, to determine the fundamental number, we have used this formula. So we have derived the root function of the number of rows. Step 2 is what we have done is we have kept the column 1 same, place the elements with column index j next to column 1, and then further place the elements with column index j which we have calculated through this formula in the next column. So we have repeated this process till this condition mentioned here remains true. Now what we have done is we have placed the elements with column index 2 to the right of the last column that was placed, and then we have placed the elements with this particular column index next to this column. So similarly we have done for the other columns also, and then we have repeated this step for the rest of the numbers. So in a given column, we have done is we have shifted the element in row 1 to the last row. This will be our last step, while bringing the element in the second row to the row 1. So we have continued this element in the top row is the one with I equals j. So we have repeated this operation in all the columns, and then finally we have calculated the transpose of the matrix A and termed it as A final. Our new matrix, we have termed it as A final. So upon calculating our matrix in such a way, we the normal matrix on the left side gets converted to the matrix on the right side. Like by following the RDCPAE approach, a 5 by 5 array would rearrange as this. So this is our short and narrow shading distribution. The first one is for TCT, the second one is for PRS, and the third one is RDFI. So we have compared it with TCT and PRS. This is for short and wide shading distribution. This is for long and wide. As you can see, the white boxes are for 1000 watt per meter square, the blue one are for 800, the green one are for 500, and the gray one are for 200. And these are the power curves. So the short and narrow GMPP, as you can see, it is 597 watts for TCT, around 7000 watts for PRS, and 737 watts for RADF. And for short and wide, the maximum power output for TCT is 556, 673 for PRS, and 706 for RD. And for long and wide, the maximum power output for TCT is 522, for PRS it's 662, and 700 for RADFI. These are our performance parameters for short narrow, short wide, and long wide. So we have the main performance parameters are MPL and FF, that is mismatch power losses and fill factor. So these are our results. So the average increment in GMPP values for the 9x9 array is 28% in contrast to the TCT, and 4% when compared to PRS for all the discussed shading scenarios. And the average increment in the fill factor is 9.4%, and the decrement in the mismatch losses is 18.7%. So the results have been analyzed based on the maximum power output, fill factor, and mismatch power losses. So our results clearly demonstrate the superiority of the suggested reconfiguration strategy. Excuse me. So here I would like to conclude our PPT. So the current study proposes this novel reconfiguration based on RADFI through simulations. We've used MATLAB Simulink for the simulation, and it works well for 9x9 PV arrays with short wide, short narrow, and long wide shading patterns. Thank you.
Excuse me.
Hello.
Can you show your first slide?
Showing on me, yeah.
First slide meaning this.
Title one, ma'am. Title one. Yes, ma'am. This one. In slideshow mode, ma'am. Oh, okay, ma'am. Thank you.
Yes, Isha. Hello. Am I audible?
Yes, you're audible.
Uh, yes, Isha. It's a good presentation by you, but I want to know that the comparison which you are showing in the conclusion, you are comparing it with basically which with the conventional one or with other methods or without using any rearrangement. You come to the
Convention.
conclusion slide. Please come to the conclusion slide.
Which slide?
Conclusion.
Okay. So we have compared it with
No,
TCP.
just before it, one slide, 16, slide number 16. Yeah, yeah, yeah. Yes, results. Yeah, you are
Yeah.
saying the average increment in the global maximum power point is 28.21% increase in contrast to the TCT and 4.86 as compared to PRS. Am I right?
Yes, right.
Yeah, yeah. Okay. Can you show me where it is you are getting 28.21% increase as compared to TCT?
Good morning, sir.
Yeah.
Sir, my name is Ish Mishra. I'm also in this paper. So, sir, the percentage increase of 28.21% is actually the average of all these three shading conditions, which are short and narrow, short and wide, and long and wide. And sir, as we can see in this graph, the first graph, that the maximum power which is produced by our method, which is by the name of RAD5, is actually somewhat around, slightly less than 750 watt, whereas the TCT method, it produces somewhat around 600, some less than, just slightly less than 600 watts. So like this, we have computed these maximum powers that have been produced, and then we have taken the averages, and then those results have been shown.
Basically, my concern is that while the reconfiguration TCT, PRS, these are very standard methods.
Yes, sir.
Am I right?
Yes,
Okay.
sir. Yes, sir.
Once these standard methods are showing that during take a case A, short
Yes,
and
sir.
narrow,
Yes, sir.
there are
Right,
three
sir.
peaks, and you have to find out a global maximum peak among these three peaks. And same is shown by the PRS also. Why in your method it is not showing the three peaks?
Sir, because the three peaks are coming, because, sir, the if we theoret
Where it is coming? I am not able to see it now.
yes, sir. Sir, the reason why we are not getting three peaks and we are only getting single peak is that when the shade is distributed upon the panels, then in a single row we are getting maximum one shaded panel, whereas in these other methods, in one row there, for example, there is one shaded, in the other row there are two shaded panels, and in the third row there are three shaded panels. That is why, like TCT has 3 to 4 shaded panels in a single row, in different rows there are different shadings of panels, therefore we are getting multiple peaks in it. But in our case, the shading is being distributed so evenly that if there is one panel shaded in one row, then there is only just that panel shaded in one row, and even in the next row we only have one panel shaded, even in the next row only one panel shaded. That is the reason why we are getting the less number of peaks.
How you are achieving this?
Sir, our method is that we have reconfigured our the TCT. We have taken a TCT array, and then we have physically taken a panel out from it, and then we have relocated that and kept it at some other place. So in that sense, what we are doing is that we are altering the positions of the solar panels. So when the shade falls on one corner of that of the whole array, then that shade gets electrically, that shade gets distributed among all the rows. That's how we are doing it, sir. The position, the way that we have positioned our panels is a very is a method which is very which we have devised, and it is very effective in distributing these shadings.
I got your point. Can you tell me how you are rearranging it? Basically, how much time you are taking to rearrange these things?
Sir, first of all, that depends upon the size of the array that we are having. So,
Okay.
what we did was a 9x9 array, and sir, we actually have performed a experiment, a physical, a hardware experiment on this, but that is published in some other paper. So, sir, it took around for the rearrangement part, it took around 1 hour or so to rearrange all the things, but to complete the experiment, sir, it took around 1 day for us.
Yeah. In suppose in depending upon the shading pattern, if you are want to change, how much time the you are taking to do so, and
Sir,
meanwhile during
the
that.
reconfiguration, once it has been set, it stays the same. We don't keep changing it for each and every
Yeah, but
shading.
you have to change the position, no? Position of the panel. Then you can basically equally divide the shades among the different strings.
Sir, we do that just once.
That's you have to do that once because that's I am saying once the cloud position is changing
Yes, sir.
or sun position is changing,
Yes, sir.
so you have to change accordingly, no?
No, sir. No. We Once we have decided what configuration it is, then it is the same configuration, no matter what the shading condition is. That is why, sir, we have three different shading conditions over here: short and narrow, and long and wide. And in all the three cases, our the way that we have reconfigured our array is performing better than these two. So even if the shadings changes, we keep our method the same. The array reconfiguration remains the same
So
in
for
no matter
so
what
for
the
whole day
shading.
you keep one configuration.
Yes, sir. All these three are the same. I mean, none of these reconfigurations are changing according to the shading that is falling upon them. They all remain the same. It's a one-time exercise when we uh, physically relocate the PV panels, and that's it, sir. We keep it that way.
Okay, thank you.
I hope I
It's from my
satisfied you,
side.
sir.
I should pass the session to sir.
Thank you, sir.
Sir, thank you. One query from my side, that's it. Isha and Isha, both Isha. One
No,
query is like in your presentation, come to your first slide, a title slide. You have written novel. First slide, title slide. You have written novel PV model rearrangement. Okay.
yes, sir.
So can you state what is novel in your arrangement? The
Sir,
novelty.
yes, sir. So thank you for your question. Sir, the word novel here represents that the algorithm that we derived, according to which we have placed the panels, that is a novel method. That is not something which has been done before. The method in which we have placed our panels, the mathematical formulas according to which we decided which panel should go where, is something that is the novelty in our work here.
Okay, means the arrangement you have done here is very novel. Means you didn't find it in any literature till now.
Yes, sir.
So you may proceed for journal then. If you are working on this and you have made a different arrangement, then you can proceed for a journal also. It's new now.
So thank
So
you for the encouraging comment.
it's a suggestion.
Yes,
After
sir.
this conference is over, rewrite your paper, design your paper like for communicating into journal, and hope you get it. You get a positive response.
So thank you for your encouraging words. And sir, we actually have published a paper in a journal already. but there were some changes in that rearrangement method that we had. It's not the same as this one. So that also is novel, and this is also a novel method. So we already have a paper based on this theme already in a journal, sir.
Okay, okay. All the best.
Thank you, sir. Thank you so much.
Just one thing.
Sure, sir.
I don't remember your name.
Sir,
Yes,
Ish.
Vinod. Yeah, yes, Vinod. Actually, you are saying that you already published it in the journal. Then how it is a novel?
Sir, as I said, that the method we used in the journal is not the same as the method we used here. Both the algorithms are two different algorithms.
Okay, okay, okay. Thank you.
Thank you, sir.
Thank
Next,
you, sir, for your time.
next paper ID 254, topic techno-economic analysis on-grid PV system for EV loads by Sumit Kumar.
Yeah, let me share the screen. Hello all, good morning. My paper title is Techno-Economic Analysis of On-Grid PV Systems.
Please
Uh,
your slides in the
oh,
presentation mode.
just a minute. Yeah, is it now fine?
Yes, sir, you can start.
Yeah. So my paper title is Techno-Economic Analysis of On-Grid PV Systems for EV Loads, and these are my table of contents: introduction, related work, proposed work, analysis, conclusion. So, in the introduction, like with the rise of EVs as a cleaner and more sustainable mode of transportation, the need for reliable and efficient EV charging has become increasingly important. A single source of energy is not sufficient for the continuous supply of electricity, so hybrid system is needed for the continuous power supply to the load. And a hybrid system which combines solar with batteries has emerged as a promising solution for powering EV charging. The performance of solar panels and battery storage are then evaluated in order to determine whether the system is technically feasible. The TEA will then choose, TEA is like techno-economic analysis, will choose the hybrid systems for EV charging that will maximize financial gains while satisfying energy demand. Homer Pro software has been used for this simulation, for this whole economic analysis, technical as well as economical analysis. So the primary objective of this research has been like techno-economic analysis of PV grid systems designed for the EV load of 246 kilowatt hour per day and having a peak demand of 36 kilowatt. Uh, so, uh, so the this contains like firstly we have the selection of site location and time series data as well as data of solar irradiance and PV systems. Like selection of system components have been there: PV panels, converter, battery storage. A PV system and an EV charging load are included on the on-grid system that is being proposed. This is the solar irradiance data for that Kurukshetra, Haryana. These are monthly data, global edge and difference. This is the graph of that. This is a semantic model of what we like designed design analysis for. We have this on the AC side we have this grid, and on the DC side we have this PV panel. We have used like total 285 kilowatts of PV panel of different ratings, like 45 kilowatts to ranging from 45 to 50 kilowatts. And the EV load, as that have already been said, like it's 246 kilowatt hour a day, and the peak kilowatt is like 35.32. We have used a converter and a lithium ion battery is there. Here you can see that the ratings of these things: system, converter, and grid. 50 kilowatt grid is there. This is the load profile. These data have been like taken from Homer software, where I did that analysis. So daily and monthly load of EV charging station operating frequency, with a 246 kilowatt hour daily charge, and the peak demand is 35.32. The charging periods have been mentioned here. This is a daily profile curve, and the yearly profile is curve is also there. Graph is there, and this is the result analysis. So, what amount of production that have been done using the different PV plates as well as the grid. 1,869 kilowatt hours per year. This is the consumption, and this is sorry. This is the average emission. We have this cost, like net present cost and levelized cost of energy, operating cost, with respect to different panels as well as the batteries. Uh, Generic 1 kilowatt lithium ion is having this total cost is around 8,687 dollars, and this whole PV panel is around this is the average energy sold to the grid. So the conclusion will be like the techno-economic optimal solution for EV load at this Kurukshetra city has been cost effective by the combination of PV with on-grid system. The study was done on the Homer software, and during this study we calculated this net present cost, cost of energy, and the operation with and that resulted in with the increase in all these operations, with increasing solar irradiation and all these things decreases with the increasing solar irradiation. The investment effectiveness of the EV charging station powered by PV will increase. We have designed this model PV grid for EV loads, calculated this NPC LCOE using Homer, and the net total net present cost is around 3,59,091.60, and the levelized cost of energy is 0.3094, which according to Homer simulation is the best system. That's all. Thank you. These are the references.
Okay, thank you, Sumit,
Yeah.
for such a nice presentation. Okay, you can you share slide number 13?
Sure. Sure, sir. Slide number 30.
Yes, and can you please come to presentation mode?
Yeah, sure.
Okay, okay, okay. Okay. You can you tell me how you are calculating this costs?
So the scene is that actually the software is designed in such a way, like if you it's a design software where you if you choose a generic flat plate PV of a particular kilowatt rating, so it will it is having that range set into his system. So based on that it calculates like
Okay, you mean to say these all are properties of the software?
yeah.
Okay, so you are basically selecting one system, and software itself is calculating all the things. Am I right?
uh, Not exactly all, but you need to be specific about what things need to be taken care of.
Okay. So now I want to know what is your contribution in this work?
Like the design of that system, like for this techno-economic analysis.
Uh, have you developed some algorithm or what's your contribution?
So this is like economic analysis. So economic analysis will be like what I have done on this economic analysis. It was with the help of this Homer software only. So for me, like that whole system was like that I referred with lot of papers, and according to that paper, like I tried to develop this thing.
Okay, you just give me example how you developed the system in Homer.
Sure.
How you realize to select this system, not the other system.
Uh, so if you like go on some references for this economic analysis of PV systems, uh, for EV loads or like simple load also. So they have like done with the various methods. Like they have used different software. This optimal economic solution software they have used. So the Homer has been like used previously also, but this system is like first of all what we do in that system is like we after the research what like whatever the system like different loads that are being taken care of, so we set that thing, and after that like we give inputs to this thing, and after that like based on those inputs and uh, and the system is having own and system is having its own capacity to like generate that optimum solution for that system.
Uh, my last question is that grid is of 50 kilowatt. Am I right?
Yeah, yeah,
And but your converter is having 100 kilowatts. So where the remaining power is going?
yeah. I think so. It's losses.
Okay, so your 50 kilowatt is the losses of the system.
Not exactly, sir.
So
So it's a like bidirectional converter has been used. So that is
that's why I
that
was
has
asking you, okay, what
yeah.
is your contribution in it?
So that this like this system that is having its own results, and like that has not been like I have that model that has not been like exactly uh, that is different from the rest of that.
Okay, thank you.
Yeah. Thank you.
Thank you.
Sumit,
Uh,
Thank you, sir. Yeah.
Thank you, sir.
Sumit,
Next paper ID 351, topic control of supercapacitors based energy storage system of DC microgrid using PI controller by Mullapati Dharni. Sir, please present your slides. Ma'am, please. So we move to the next paper ID 452, MATLAB based implementation of DC microgrid with renewable energy sources by Akash Yadav.
Good afternoon, everyone. Um, we are presenting this paper in the following order. First, there is introduction, then we have related work and proposed model, analysis, and followed by a conclusion. Next slide, please.
Excuse me,
Yes.
may I know who is presenting?
Kashish Nagpal.
Okay, thank you.
Ma'am, can you please start from the title slide?
Okay, sure. So our paper is an implementation of DC microgrid integrated with renewable energy sources. Next slide, please. Next. So we have proposed a stable and reliable three-source-based DC microgrid integrated with renewable energy sources and the use of conventional controllers such as PI controllers. It has been simulated and verified via MATLAB software and works well in non-idle conditions. This paper also discusses lead acid, nickel cadmium, and nickel um, metal hydride to store electricity. Next slide, please. So, in the literature review of this paper, we have 21 latest research papers from 2015 to 2023. These papers cover various control methods, converters, and topologies of DC microgrids and compares their pros and cons. Let me take you through first few ones. The first paper of the literature review describes the energy management of individual components in islanding mode using the DBS, that is the DC bus signaling method. Moving on to the second paper, the central idea revolves around enhancing the conversion efficiency over a large voltage gain ratio. However, it requires a complex switching strategy. Next slide, please. Next. Uh, Jumping to paper number 13, we also have studied AC-DC microgrids and their control strategies to ensure stability and voltage regulation. I request now Akash Yadav to please take on from here.
Studying about the proposed work in this paper aims to address the challenge of implementing a stable and reliable DC microgrid. The paper also explored the different source-based DC microgrid. The first source we are using is utility, then solar-based source, and then the wind-based. It compared three different type of batteries that is used as a backup in our DC microgrid. Now we will be giving some points about the implementation of DC microgrid on MATLAB simulation. The implementation of MATLAB model involves simulating the proposed DC microgrid system in a non-ideal realistic environment. The model was designed to incorporate the selected parameters for the solar and wind system along with the controllers. The Simulink model was used to demonstrate the sinusoidal characteristics of a grid voltage, that is AC grid, when the load is turned off and the instability caused by exceeding critical value of irradiance and wind speed. The MATLAB simulation result demonstrated the well working of the proposed system and provide a clear distinction between the three different type of batteries used as a backup in the Simulink model of DC microgrid. Now turning to the analysis part, this first simulated outcome is with no load. We are here seeing 8 graphs. On the first we have the utility DC microgrid. Here we will giving the three-phase supply with the phase difference of 120 only, and as there is no load, so we are getting the voltage as it is. All the values on the rest of the graphs are zero, except the battery. It was initially charged up to 50%, so it is showing the level of 50% only. Moving on to the next graph, the next simulated output is related to the grid voltage, bus voltage, solar irradiance when wind speed is set to 0. At a irradiance of 1000, the graph shows a switch from the initial AC source to the source PV, suggesting seamless switching between sources. The PV array's effectiveness directly depends on the irradiance, leading to higher energy generation with increased solar radiation. However, the graph also indicates a limit to irradiance beyond which the system.
Yes, Akash.
Yes, sir.
Your figure is not clearly visible. It is, I
So
am
the
unable
first,
to see what is the. Kindly use the pointer. है ना?
yes, sir. So the first
And
graph, this one is of the grid utility source. I am currently talking about the second only. It is for solar PV array. As soon as when there is a switching between the AC source and the PV,
there is a seamless switching between sources, the PV array effectiveness directly depends on the irradiance, leading to high energy generation with increased solar radiation. However, the graph also indicates a limit to irradiance beyond which the system includes the lost breakdowns. Factor like PV array capacity and system design may contribute to this limitation. Moving on to the next graph, we have simulated outcome related to grid voltage, wind speed, and bus voltage when the solar irradiance is set to 0. In this graph, we are looking at the first only, that is the AC signal, and then we will be looking at the wind, that is the third graph, the yellow one. The graph shows a switch from the AC source to wind store, indicating the system ability to effectively transition between the source based on condition. Notably, solar power was initially disabled, highlighting exclusive reliance on wind speed. Moving on to the next graph, we have the simulated outcome related to grid voltage, solar irradiance, wind speed when the load is turned on, excluding PI controller. In this graph, for solar and wind speed, we will be looking at both the on starting three graphs also. For solar and wind power utilization, a PI controller is essential due to their intermediate nature based on weather conditions. The PI controller combines proportional and integral control to stabilize power output, compensating for renewable energy variation. Without it, the load will suffer from unstable power delivery, unreliable performance, and potential equipment damage. So we are using the PI controller to control all that thing. Now Hardik will take over.
So now moving on to the comparison of all three different type of batteries used in our proposed model. So first we move on to the lead acid battery here. As we can see that the initial charge level is at 50% for all the three batteries. When the supply is just cut off, the peak charge level is at stated 50.0125%. And when the all three renewable sources, including the AC grid, when the load consumes power from the battery, after the system is turned off, the discharge level is stated at 50.0065%. From all these three values, we can then obtain percentage increase and percentage decrease for all the three batteries, including the nickel cadmium and nickel metal hydride batteries. So stating from the following table, we can then conclude that the following result. Just keep in mind that the Simulink model for the comparison of batteries has been run for over a duration of 5 seconds. If the duration we further prolong, the results may vary according to the duration. So during the 5-second duration, we can see that the lead acid battery performs slightly better than the other two batteries, nickel cadmium, nickel metal hydride. But we did not just increase the time to further more like practical durations. So results may vary according to the further durations. Next slide. So moving on to the conclusion, in our proposed DC microgrid system, we have included AC grid and two further renewable energy sources such as solar and wind, including further backup used as batteries, which include three different type of batteries: lead acid, nickel cadmium, and nickel metal hydride. From the following proposed system, we can then conclude that if the PI controller is turned off, the load doesn't utilize other renewable sources of power, and the switching doesn't go according to the plan. We can then see in the following figures, which has been passed into the upcoming slides, that if we increase the value of irradiance and wind speed from a certain level to which causes the instability of the system and which leads to the further breakdown of the load. Next slide. So there we conclude our following presentation. Here are some few references that we have taken in sight of our paper. Thank you.
Thanks, Hardik, for the presentation. Hello.
Yes, sir.
Yes, can you come to slide number 14? Slide number 14, yeah. What do you mean by peak charge level?
Peak charge level is that when the load is consuming power from the other three sources such as AC grid, wind and solar. The battery just charges for over that duration of time. Let us suppose when you plug in your phone and phone is on standby, like nothing screens on, nothing anything, the phone charges. That is the peak charge level, like from which the load doesn't consume the power from the battery. That is the peak charge level. It doesn't state that the battery can only charge to that level. If we further increase the time from which load doesn't consume power from the battery, just from other threes our sources, the battery can also charge up to higher duration. That is the peak charge level.
Okay, so you mean to say the lead acid battery means can charge effectively as compared to nickel metal hydride?
Yes, for the duration of only 5 seconds. If we further increase the duration, the proportionality can differ according to the duration.
Okay, so is it possible if you are going to see it for 5 minutes, then maybe nickel cadmium is going to be best one among the three?
Yes, it could be possible. However, nickel cadmium can operate at a higher temperature, so that could lead to the deteriorate of the nickel cadmium battery.
Okay, but I think why you have considered only 5 seconds? Yeah.
Sir, we have considered only 5 seconds as we didn't go into the that aspect. Like for a DC microgrid to function properly, you have to take a period of I think 24 hours or I think 36 hours to see its functionality properly. However, with our resources, we can not demonstrate for that duration of time, how 24 hours or 36 hours.
You are
So
using MATLAB, no?
yes, we are using MATLAB.
Then you can, I think you can do it in MATLAB.
We try to do it, sir, but when we just increase the time for we implemented for 3 hours. Okay, so after a minute or 2 minutes, the system started to deteriorate. Not the our proposed work, the system on which MATLAB was running.
Okay. And there is a general suggestion that your figure qualities and table quality is not good. So
Okay,
most
sir.
probably from the proceedings are going to Springer. So mostly probably the comment will come from Springer also, because I am unable to see what is the different labels which you have marked in the figures. Can you come to the figure number 3? See, I hope you are also unable to see it clearly.
Sir, actually, in the paper, not in the PPT. Actually, in the paper, we have used a different. You use the exact same figure, but just a higher bit of quality.
So you should show it
We
here
we
also.
we forgot to change here. Just that's our mistake.
Okay, if you are saying that you have done in the paper, then it's good.
Yes.
Figure 13. I was figure 3. I was talking about figure 3. Figure
Yes.
3. Figure 3. Figure 3. Figure 3. Yeah. Here it seems that you have stopped the simulation without going to up to the last point. Am I right?
Yes, the graph doesn't reach at the end. Yes.
So there was certain specific reason for stopping it,
Uh,
or
no,
your
there
system
was
goes to be deteriorate at this time.
no. The system didn't deteriorate at this point. Actually, what happened that it did go at the end. Just simply we did capture the image of at that point. We the image which it shows that it got all the way along towards the end. We have included in the paper itself.
Okay, thank you. I pass the session to the sir. Next session chair.
We now move to the next paper, paper ID 457 on the topic Belief Reliability Evaluation of F18 LLF System by Disjoint Method, presented by Roopshi Gupta.
Yes, am I audible?
Yes, ma'am, you're audible.
Okay. Good afternoon, everyone. My title is Belief Reliability Evaluation of F18 LLF System by Design Method. So, going to the next slide, let's have a look at the table of the content. First, the introduction, then related work, then proposed model and work, result analysis, conclusion, and the references. Let's coming to the introduction. Let us suppose if we have to calculate the probability or the capacity of a system to perform its specific task for a specific duration, then mathematically we have to calculate its reliability in terms of the probability by using the probability theory. But the excuse me, but initially when it was discovered, so issue with the system was that it contains both type of uncertainties, that is aleatory as well as epistemic. But initially only aleatory uncertainty was considered, that was because of the inherent uncertainties of the system, but the epistemic was ignored totally because no such mathematical calculations were there to include that. So in my research, I have included that epistemic reliability by using new or a novel method, that is a design method that overcomes all the disadvantages of the traditional methods, that is decomposition method. So I have taken practical system, that is F18 LLF system. That is an aircraft basically that is used to hit a target, and I have calculated the whole system's belief reliability by using its reliability block diagram. So that is what the introduction is. Then next, coming to my related work, I have introduced about the F18 LLF system. Then I have introduced that disjoint approach. By using that approach, I have evaluated its belief reliability. And the components of rotorcraft system are as follows: FCC, that is Flight Control Computer Channel, Hydraulic Servo Actuator, LLEF, and RLEF. Next, coming to the block diagram of F18 LLF system, that is the model. From that model, I have created my RBD, that is reliability block diagram. In that, I have clearly seen that we have first, second, and seventh component is aleatory, while rest of all are epistemic components. So I have discriminated that components by shading them. Coming to the reliabilities of the respective components, R1 has a reliability of 0.9688. Then coming to the last RB, that is reliability of the ninth component is 0.9500. Then first, as proceeding towards the disjoint method, I will calculate. I have calculated all the possible paths from the source to destination, as shown in the diagram. From source to the destination, I have evaluated all the possible paths. That is, the path one is from through first component. I can go from source to destination. Similarly, from by following the path through second component and third, then fifth, sixth, fifth, ninth, eighth, sixth, and eighth, ninth, then 4, 5, 7, 6. Then I have calculated all the paths, possible paths. Then I have calculated the disjoint probabilities of all the paths by following some proposed rules that is predefined in the probability theory as well as uncertainty theory. That for example, in our set theory, if I have taken the union, then in my belief reliability evaluation I will take the minimum of the probability of the two components, whereas if I take intersection, then in the belief reliability I will take the maximum, that is maximum of the two components. Then, by following that proposed rules, I have evaluated the disjoint probabilities of all the components, that is, of all the parts, that is, first to eighth.
And then I have calculated the overall system's belief reliability by just following that first plus second plus third. Then I have solved or simplified that expression. Then I have just put it that reliability values in that expression and evaluated finally my belief reliability as 0.9717. That is my proposed work. Next, coming to the result analysis, through my described method, I have encountered that 0.9717 belief reliability of the system is coming. But if I will calculate through it through a decomposition method, that is a very large method. In the decomposition method, the number of the terms were number of the expressions were approx 58 to 60, whereas the described method, there are very less number of expressions. We can see that 9 to 10 expressions only. So by decomposition method, it was coming 0.9725. Only a negligible error of 0.008 is coming that we can ignore or round off. If we can round off, then we can just quantify our new method. It is design method. And that is the conclusion that I have taken practical F18 LLF system, and that is represented by its corresponding block diagram, reliability block diagram, and numerically then belief reliability is calculated using by using some predefined rules for the reliability as well as belief reliability. So that is a very new approach or a very effective approach for the less number of the calculations, and that is also a benchmark problem in reliability literature. And these are my references I have used. Okay, thank you.
Yes, thank you.
Thank you.
It was a good presentation. Actually, I am not expert from this field. Can you tell me what do you mean by LLF?
Sir, it is a basically landing and launching facility that is basically used for the aircraft. These are used to hit a target.
Full form of LLF.
It's a landing and launching facility.
Okay, landing and launching facility. Okay.
Yes, yes, sir, yes, sir.
So you have basically done the reliability analysis of it. Okay.
Yes, yes, a belief reliability analysis of that system.
Okay. Basically, you got some. How much percentage you are getting improvement in your reliability analysis?
Sir, actually, I was getting a error of 0.008, and simply if it is a negligible error, because I have just simplified my method rather than the previous method. That was very large method, big method. So,
But I think the 0.9717 is the standard one.
yes, sir.
Okay, so I think you should compare your method with other methods which are basically recently work on it.
No, actually, sir, I have simplified or I have compared with that decomposition method only. But in the for the future perspective, I will sure I will do or I will use another methods also.
Okay, okay, thank you.
Okay, thank you, sir.
Thank you. As we're running short of time, we request the next two participants to be brief about the presentation. We have paper ID 351 on the topic control of supercapacitors based energy storage system of DC microgrid using PI controller, presented by Mulapati Dharani. Dharani. Sorry.
Hello, ma'am.
Is my screen visible, sir? Yes, we can. Thank you. Good afternoon, everyone. So the title of my paper is of supercapacitor based energy storage system in DC microgrid using PI control. So these are the table of contents which I am going to explain. First one is introduction about the DC microgrids and the supercapacitors using in energy storage system and what the research work I have done and the control strategy, the simulation results, conclusion, future directions and references. So just I have to give a brief introduction about the microgrids. Here we can see a microgrid structure. This is a small scale power grid that can be operated independently or in combination with the of main electrical grid. So, so next one is about a DC microgrid. So here we can see a DC microgrid which is connected to a PV array, that is a solar panel, and which is converting to DC using a converter. And here we are using a battery which is an energy storage system, and it is also using a bidirectional converter from DC to DC, and this DC is supplied to the DC loads, and if you want to supply for the grid, then this DC is converted into AC and it is given to the utility grid. So what are supercapacitors? So this is a new type of energy storage system between the common capacitor and the secondary battery based on the electrochemical double layer principle. So it is reversible with chemical reaction. So the supercapacitor can be charged and discharged hundreds of thousands of times. So its power density is equal like nearly 100 to 10 to 100 times than that of conventional batteries. So one has several advantages compared to batteries. So the first one is high power density and fast charging and discharging, and the one is long life cycle and reduced size and weight, low
Yes,
maintenance and high
Dharani.
efficiency. Yes, sir.
Yeah. Can we do one thing? Can you come directly to the work instead of discussing this introduction part? Okay, thank you.
Yeah, sure, sir, sure. So what the research work I have done is, so my primary objective is to design and implement a PI controller to optimize the charging and discharging of a supercapacitor, which I am using in the DC micro. So this involves the design and simulation of a control system using a PI controller, which can manage the supercapacitor state of charge and also can maintain the DC bus voltage. So this is implemented in Matlink platform. I have done some simulations, and the control strategies performance was evaluated under various scenarios. I included fluctuations in load and also renewable energy generation variation in the availability. So what is my control strategy here is I used a proportional and integral controller. So the proportional terms, what it does here is the control action in respect to the current error, the error which I am getting. So it proportionally controls the error, and the integral term accumulates the past errors, so which errors had already happened to precise the voltage regulation. The controller's gains were tuned to optimize the performance under dynamic conditions. So what outcomes can be expected from my simulation results are this: the PI controller will enhance the performance of have got. So here we can see the PV voltage, PV current, and PV power. So here you can see initially the
Ma'am, we are not able to see your presentation. Ma'am, are you there?
It depends on the PV panel's irradiation condition from 2 to 4. This supercapacitor voltage, current, and power. So,
Excuse me, ma'am.
the
Ma'am, your slides
supercapacitor
are
is
not
charging and discharging. Sorry.
your slides are not visible.
Hello.
Ma'am, your slides are not visible.
Can you please check now?
No, they're still not visible. Please try resharing your screen.
Yeah, sure. Is it visible, ma'am?
Yes, now it's visible.
This is the state of charge of supercapacitor, like it is charging and discharging, and it is not like degrading completely. So the conclusion is this paper aims to demonstrate the effect in like the PI control in optimizing the operation of supercapacitors. So by improving the voltage stability, this research can further promote the adoption of supercapacitors in DC microgrid applications. So the future directions can be like we can use advanced control strategies like model predictive control algorithm, uh, real world implementations to validate the simulation results. So additionally, the integration of supercapacitor based systems into larger DC microgrids network should be explored. So there are some references I have used. Thank you.
Thank you for such a nice presentation. Actually, I want to know how you have tuned the PI controller.
Thank you, sir. Thank you so much. Thank you, sir. Sir, am I audible?
Yes, you are audible. Actually, I want to know how you have tuned the PI controller.
Sorry, sir. How I have tuned the PI controller?
Yeah.
Tuning is in simulation. In the basis of simulation, I've tuned in simulation. Sir, platform, MATLAB.
Basically, you auto tuned with the MATLAB.
Yes, sir. Yes, auto tuned with the MATLAB, sir.
Then, what is your contribution in it?
My contribution, like previously batteries was used, sir. So I used here super capacitors.
With the do you know the drawback of supercapacitor as compared to battery? You are
Compared to battery.
what I am able to understand. You are proposing supercapacitor as a energy storage as compared to battery. Am I right?
Yes, sir. Comparative battery, supercapacitor is somewhat best. What I
No, it's
went
not
by
like
this.
that. Actually, you cannot say that supercapacitor is best as compared to the battery. Uh, Basically, can you tell me what is the advantage of
Like considering charging.
No, actually, supercapacitor do not provide long-term power. Instantaneous power it can provide, but not for a long duration.
Yes, sir. Yes, sir.
So, in long duration power supply, it is going to be failed. Suppose in your home, if you are going to replace the inverter battery with supercapacitor, you are going to fail. Are you getting my point?
Yes.
So basically, That's why I want
Actually,
to
like
know.
for rapid charging and discharging.
Rapid charging and discharging, it is okay. It can rapidly supply. You can use supercapacitor in parallel with the battery, but not just replacing the battery with the supercapacitor. It is not possible for a long duration. For a very short duration, instantaneous, or you can say transient periods, it is possible, no, but not for a long duration. That's why you are seeing its discharging pattern. It is going to be very this state of charge is going to decrease very fastly. So I think you should think about some alternatives. You can use supercapacitor in parallel with battery, but I don't think so. Okay, you can completely replace the battery with supercapacitor for a energy for a DC microgrid. And second, my suggestion is you.
Yes, sir. I have tried using in parallel. Yes, sir.
But nowhere you have shown it here, no? In parallel with battery.
No, sir, not now. I have tried using that, but I have like to innovate newly, so I used only supercapacitor. So I removed battery and I only use supercapacitor.
Okay, okay, thank you. Thank you.
Thank you so much.
Thank you, ma'am. Now we move to the final paper, paper ID 461, on the topic impact of PWM techniques and level variation on THD performance in single-phase cascaded H-bridge multi-level inverters, presented by Saryu Rani.
Ma'am, my screen is visible.
Yes, ma'am.
Good afternoon to all of you. My paper ID is 461 and paper title is Impact of PWM Techniques and Level Variation on TSD Performance in Single Phase Cascaded Edge Multi-Level Inverters. Table of content, introduction, related work, proposed work, result analysis, conclusion, and then references. Introduction. Multi-level inverter are improved alternative device to regular two-level inverters. The current and voltage waveforms are generated in staircase form. There are number of advantages of cascaded H-bridge MLI, such as harmonic content is less at higher levels, eliminating the need of filters. They draw input current with very low distortion. They can operate with a lower switching frequency. It is very convenient to control CHB inverters as compared to other MLIs. Weight and cost of CHB inverters is less than other MLIs. Applications of the CHMLI are used in high and medium power motors, drives, electrical vehicles, solar PV panels, power
Yes,
cycle
Saria.
compensators. Yes, sir.
Can you please skip the introduction part and come to directly
Okay,
to
sir.
your work?
Okay, sir. In this paper to analyze the impact of cascaded H-bridge multi-level inverter and compare the total harmonic distortion of different levels of cascaded H-bridge multi-level inverter using level shifted pulse width modulation technique. The different levels of MLI is simulated and the result is analyzed to determine the THD. To determine the TSD of different levels of MLI using different PWM techniques by applying the FFT. Total harmonic distortion is an important parameter used to assess the quality of the output voltage waveform in MLI. Different levels of multi-level inverter and PWM techniques. Can we have varying effect on THD? Let's compare the THD of different levels of MLI inverters using different PWM techniques. And this is a simulation result. The table is also shows that the phase reposition technique at the 15 level is the TSD is 6.85. This is also show that the TSD is very reduced at the 15 level as compared to other techniques. Conclusion, it is concluded for obtained simulation results that the different levels of cascaded H-bridge multi-level inverter using PWM techniques, it is analyzed. The PD technique is achieved minimum TSD as compared to the other PWM techniques. Result shows that the harmonic distortion has reduced, leading to an improved voltage waveform at the output side. And these are the references. Thank you so much.
Thank you for such a presentation. I want to know what is basically your contribution in the work, because the phase disposition, phase opposite disposition, and alternate phase opposite disposition techniques are already available in the market.
Yes, sir. But I analyze improve the THD. I compare the other papers.
So that's why I want to know what is your contribution in this work. Can you come to that table?
Yes, sir.
Yeah. अब आप लोग नमाज के बाद आइएगा, मैं नमाज के yes.
Yes, sir.
Sorry, actually, I am in the department, so yes, please. Yeah. So what's your contribution?
Sir, I analyze the PW is a better. I know that other papers are published, but sir, I compare the different papers. Then my THD is very improved.
I mean to ask, have you developed the model of these 15 level, 13 level, 11 and 9 level inverters?
Yes, sir.
Okay, you have modeled it, then implemented the PD, POD, APOD, and then compared
Yes,
it.
sir.
Am I right?
Yes, sir.
This is your
Yes, sir.
contribution. Okay, thank
Yes.
you. Thank you.
Thank you so much, sir.
Thank you all. Now I kindly request Dr. Farhad Ilahi Baksh and Dr. Amit Kumar Chaudhary to provide their closing remarks for this session.
Thank you, ma'am, for giving me chance to session this chair. Basically, overall, the paper quality was very good, and everyone have done some or other point of work at different points, and it was quite interesting session. I learned a lot from this session. Few papers was out of my scope also, but I done my best to evaluate those papers also. So I wish all the presenters and all the organizers best of luck for the future endeavors.
Thank you, sir. It was indeed a very good session, and we are very happy that you joined us and you just give the feedback for all the participants. Thank you very much, sir.
Thank you, ma'am.
Thank you, session chairs, for your valuable contribution and leadership in this session. An important announcement: all presenters will receive their certificates via email after the conclusion of RDCPAE 2023. I now extend my heartfelt gratitude to all of you for your valuable participation. You may now leave the session. Thank you.